Informative speech on the science of cloned livestock. Cloned animals are upon us. This is not something out of a sci-fi horror movie, though. These clones are exact genetic replicas of animals with the most desired traits. I show steers in 4-H and 4-H, and clones are more popular in the club calf industry. This led me to becoming interested in this topic, so I wrote a FFA project report over this a couple years ago. By no means am I professional, but I have done a fair bit of research. So today I'm going to share with you the information I have learned about the science of cloning, why people may decide to clone, and the lives of clones. There's a lot of science and big words that come with the process as complicated and advanced as cloning. There are two main methods of cloning we'll go over. There's been many studies done by universities and the FDA to figure out both of these methods. The more simple of the two methods is cell splitting cloning, where according to a paper by UC Davis's Allison Van Heineman from 2006, cell splitting cloning can occur naturally and be artificially replicated. This is when a fertilized embryo splits and creates two genetically identical twins. Another method is somatic cell nuclear transfer, or SCNT. This is the method of choice for Transova Genetics, a company that clones and provides other artificially reproductive services as well. Diane Brock of Transova has provided lots of information on cloning in the resources tab of their website. Somatic cell nuclear transfer has many steps and is a very complex process. The first step includes collecting a tissue sample from an animal you're wishing to clone. Oocytes or egg cells from donors are then enucleated and the nucleus is removed. The nucleus from the collected tissue cell is then reconstructed into the enucleated donor oocyte. From there, the reconstructed embryo is then stimulated with an electrical pulse and is placed in a synthetic oviductal fluid for up to 6 days to ensure that the nucleus sticks. From there, the embryo is then placed into a surrogate to birth and raise the clone. There are other minor steps along the way, but you get the general idea of the process. By now you may be wondering, why clone livestock at all? There are many benefits to cloning. Clones of the most productive and most genetically desired traits will be just as successful as the original clone was. The FDA gives many reasons in their 2021 report on the methods of cloning, on the reasons why people may want to clone. One example includes, if a rancher has a bull that produces the top best-selling calves every single year, you may want to keep that bull. And after 4 to 5 years, bulls start to decline in productivity. And if that rancher would like to keep that bull as long as possible, so having a clone of that animal you could hypothetically extend that animal's life forever and ever. In 2006, professors and students at the University of California, Davis started to do some research on cloning and claimed animals can be used for medicine as well. Pigs are being cloned and research is being done to hopefully help aid in xenotransplantation and stop organ rejection and retransplant surgeries. Cloned pigs don't have the same genes that cause rejection. Scientists can clone these pigs as many times as possible to get as many of these non-rejectable pig organs as possible. Diane Brock and Transova claim in a report from August 2025 that they could preserve lost genetics through cloning. They can clone dead animals if the cells were harvested prior to death or shortly following. They can also create intact clones that are able to breed from an animal that has been previously castrated, as well as clone sick or injured livestock. Some may be asking, what is the success rate of cloning, and do these animals live regular abnormality-free lives? Cloning has been tested in many different labs and universities across the world. It is a costly process with a low success rate. Andreas Gambini of Merck Vet said in his 2025 report, made it very clear that if a clone does stick, it is not out of the woods yet, because 30 to 50% die before they are 4 years old. He also shared a few common complications and abnormalities that could arise with cloning. The species being cloned plays a part in the success rate. Goats are the most successful, with 10% being cloned successfully. Sheep, cattle, and horses are tied at around 5%. Pigs, cats, and dogs, and even a few camels have been cloned but are less successful. There are a few complications with cloning too, that many occur during gestation, birth, or the postnatal phase of life. Failure of the placenta to develop is the main cause of death in clones. Placenta dysfunction may not be a problem during pregnancy, but can catch up later. Scientists believe most of the anomalies can come from an issue with the epigenetic reprogramming of the donor's genome after nuclear transfer. This leads to genes developing incorrectly. It has been noted that these problems stop at the clone, and if the animal survives to a natural adulthood, their natural offspring will develop normally. All in all, you can now see that cloning is a very complex process that works for some livestock producers and in science. It is not for everyone, though, due to the low success rate, the anomalies that could arise, and is a very expensive method of artificial genetic reproduction, costing upwards of $20,000. Now that scientists are cloning livestock, who knows what will be cloned next? Maybe one day you will actually be able to be in two places at once, like the sci-fi movies depict. Thank you.